All right, guys. So in this lesson, I'm going to introduce the concept of a new distribution we're learning in this lesson. This will help us understand the next lesson better. So the title is Sampling Distributions. So the first question we have here is, what is a sampling distributions? It says that a sampling distribution of a statistics, and that statistics can be, sample means or proportion or variance. So that distribution consists of all values of that particular statistics. So if we're looking at a distribution of all sample means, we're looking at that distribution of all possible samples of the same sample size and taken from the same populations. So it is a lot in that two sentences there. I'm going to try to demonstrate that through a picture here, and then we'll get to this example after the picture. So it's pretty much what we're looking at here is not focus on the distribution of the values of the sample taken from the population, but more of like focus on the distribution of the sample means from each sample and see what we get out of that, okay? So let's start out by drawing the populations here. So suppose we have a population. Let's use red to denote the populations, okay? So let's say this is the populations. Okay, and then from this population, it probably has some sort of mean and sigma. We don't know what the value of mean and sigma would be. The first thing we do is we're going to go ahead and randomly select the n values. Okay, so let's say we have a sample one of n values, a sample 2 of n values, and then sample 3 of n values. And then suppose each of this sample has a size n, so size n, whatever that could be, right? Dot, dot, dot. So the first step is randomly select n values or n samples of certain size n. We don't know what the sample size would be. We don't know how many samples we're picking. But the next step, what we're going to do is we're going to compute the sample means, the sample means of each sample. Okay, so in other words, we're looking at x bar 1, that is the sample means for sample 1, x bar 2, x bar 3, and etc. Okay, so this part is the sample means. Okay, and then the next step is go ahead and plot all the sample means. Okay, what that means is we're going to go ahead and plot. We're going to go ahead and plot all of these here. So we're going to plot all these x bars here. Okay, let's go ahead and plot that. It turns out that if we were to do that, these x bars will look like this here. Okay, and I'll tell you guys in a second what I'm doing here. It turns out that if we do this, if we plot all the x bar from the samples that we draw from the populations, it turns out that the distribution of all these x bars, all the sample means, is somewhat approximately normal. So we say the distribution of all these x bars is approximately bell shape or normal. Okay, regardless of what the distribution of the population might be. Okay. Right. So what we're saying is that if we were to do this, we're given a population, we draw some sample from that population, we'll compute the sample means for each of those samples, and then we plot all those samples. We create a distribution of all the sample means, and it turns out the distribution of all the sample means is somewhat approximately normal, given that the sample size is large enough, regardless what this population, regardless what the shape of this population distribution might be. And so that's kind of neat. So this result here, we're going to use in the next lesson to solve application. If that doesn't make sense there, I'm going to show you an example using this data here. So this example we're going to use. So the data is going to be the student's last 4 digits of social security number in random order. So we're going to generate a list of last 4 digits of social security number, and then we're going to compute the average of those digits, and then we're going to plot those averages, and hoping that we have a bell-shaped distribution of all those X bars from the last 4 digits of social security number. Okay, so let me just go ahead and briefly kind of sketch that here. So if we were to, let's say X is the last 4 digit of social security number randomly. Let's say we have 1, 3, 4, 5, 6, 7, 8, 9, 0, 1, 0, 1, 5, 2, 7, 1, 5, 7, and so forth. So these are the sample drawn from the population, and then the X bars value will be the average of these digits, right? So X bar, so the variable X bar that we need to plot would be the average of the digit, the last 4 social security number. Now, we can show this here, but it turns out what we've given here, if we look at this distribution or this data set here, if we plot all the last 4 digits of social security number in random order, that distribution will be uniform. And I'm going to show you guys that in a second, in a bit. And we're hoping that if we plot the distributions, we plot all the X value, X bar, we're going to get somewhat a normal distribution. Okay. So I'm going to go ahead and switch screen to go to Excel. I'm going to show you guys this example in Excel here. So new share, desktop, okay, and Excel, new. All right, so I'm going to go ahead and do a random generated last 4 digit of social security number. So the first one here, I'm going to do random between 0 to 9. All right, and then let's do a sample size just 20 here. And then I'm going to do this for all 4 column because I need 4 digits. So, and then I'm going to go ahead and record these 20 last 4 digits of social security number. So how I'm going to do this, I'm going to go ahead and do that times 1,000 plus that times 100 plus that times 10 plus the last digit, so we don't need times anything there. All right. Now, because these columns, these values are randomly generated, so each time I click on this cell here, it's going to keep random generate each time. So it won't affect what we're trying to get though. So these are the 20 random last 4 digit of social security number that we just generated. We're going to take the average of these digits, and then we're going to plot all those averages. Okay, so this column here will be the average of those digits. So we're going to say average of these digits. There it is. And then we're going to go ahead and copy that to 20 cells. Okay, so this column here represents a sample from the population. So what we're going to do is we're going to plot these here. These will give us a somewhat uniform distribution. So I'm going to show you guys how to plot that. Go ahead and insert a cell. Okay, so I'm going to go ahead and plot all these numbers here. It's going to be a uniform distributions. So we're going to use the countif command, and then that. So this tells us the frequency of each of this number. Okay, and it's gonna be all one. So go figure. So what we do here, we're do a scatter plot of this, and then it's gonna be a somewhat uniform distribution. Well, it is uniform distribution. So if this is the just taking 20 values from the last 4 social security number digit randomly, the population. So this represents the population distribution is somewhat uniform. So the next thing we're gonna do here, we're gonna go ahead and plot all of these X bars. These are the sum or the averages of the social security numbers digit. So we're gonna do another command of countif, and then we're gonna do that, okay, and then highlight this here. So now we have all the X bars here, all the frequency of the X bar. We're gonna go ahead and do a scatter plot of all these X bars here, which is a dot plot essentially, and see what kind of distribution we're gonna get here. So insert charts, that, okay. So let's move this over there, move this right here, okay. All right, so you see the distribution of, so I guess this will be distribution sample means, and then this will be just the population distribution from just a sample. So notice that it's already slightly different. This will be a non-uniform. The distribution of sample mean is non-uniform. This is uniforms. So we're gonna try to see if we get somewhat roughly normal if we increase the sample size. Okay, so I'm gonna go ahead and increase the sample size from 20 to 50. Drag this to 50. 50, and I'm gonna zoom out just a little bit. Okay, 50. So I'm gonna go ahead and drag this over as well. Okay. All right. Drag this down. I want to do this one right here. Drag it down there. Down there. Okay. So now I'm gonna go ahead and highlight this here. So this now will give us a dot plot or a scatter plot of all the X bars of 50 random last 4 digit of social security number respective frequencies. So I'm gonna go ahead and insert and then do scatter plot. Go ahead. So now you see it's looking a little bit more better than this one here. Right, so it's somewhat, it's getting close to approximately normal. Now each time I reset the random generator, so what I'm going to do is I'm going to try to attempt to see if it's going to change favor a little bit. So let's go ahead and do that. Okay, so that didn't help much. Let me try one more time here. Okay, that's a little better. So now this graph here will be a new set of 50 random last 4 digit of social security number with respect to the sample means we plotted. So it's looking a little bit more normal. This missing part here. So if you guys want, we can go to 100. Let's try to 70. Let's go to 70 and see what we get. A better distribution, somewhat normal or not. Okay. That. Copy. All right, so this will be the distribution of sample means, sample size of 70 random last 4 digits of social security number. Okay, so look at it. That looks a little more normal now, somewhat approximately normal. So I'm gonna go ahead and screenshot this here. Well, I mean, I can use my Apple Pencil to draw in here so you can see that it's gonna be somewhat normal. I don't know how to do a density curve fit through this, but I can screenshot this graph and drop into my iPad and then draw the, it won't let me. Oh well. Okay, so now it changed the shape again because I clicked on it again. So let's do that. Let's see, much better. So see if I can do a screenshot. Can I do a screenshot of this? Okay, there we go. And I'm gonna go ahead and export this to my iPad so I can draw. I don't know where that go. Anyway, so the whole point of this is that as we increase the sample size, the distributions of X bars here, so this would be the distribution of X bars, the larger the sample size, the many there are, the more normal will get, and then it will approach even normal. We're gonna go ahead and apply this result in the next lesson. That's just really important. We can do the same thing for the sample distribution of proportions or variance. I just demonstrate this just through a sample means, but it works the same thing as if it was, distributions of proportions or variance. I'm gonna go ahead and switch screen again to the iPad and finish this lesson here. All right, so moving back to this lesson. It turns out that we have a definition describing estimator. So if we use an X bar or a sample means to estimate the population's mean, that value itself is considered to be an estimator. And there's two types of estimators. We have a biased versus unbiased estimators. So unbiased estimator is a statistics that targets the value of the corresponding population parameters, okay? In the sense that the sampling distribution of the statistics has a mean that equal to the corresponding population parameters. So unbiased estimators, those are sample means, sample variance, and sample proportion, okay? These statistics will target the value of the corresponding population parameters. And bias estimators, these values don't, so the bias estimators that do not target the corresponding population parameters. And those are standard deviations, range, and median. Okay. In the next video, I'm going to show you guys a much better simulator of this result here. But that's pretty much for this video here. I just want to show quickly what is the sampling distribution. Okay, it just means we plot all the sample means, all sample proportions, and create a new distributions. This is what the picture would look like, and I also show in Excel what would be if we would just do an actual data set. So hopefully that makes sense, and if not, I'll answer some of these questions on Zoom section on Wednesday.